Today I want to talk about something we see every day in the field, our field, rural connectivity challenges, and more importantly, how we're solving them using LAN bonding and AI-empowered edge networking. A little bit about who we are. Richardson Engineering, we have 70 plus years of combined industry experience across our whole team. We work pretty much with anybody, but our main focus is in rural and remote connectivity areas, people that struggle with broadband coming in, and help them get the solution that they need. You guys can all hear me good, right? Oh yeah, okay, perfect. So today, I'm going to walk you guys through a few things. First, we're going to go through rural connectivity challenges, then we're going to talk about true LAN bonding, and then we'll talk about our AI edge networking, and then real-world applications and solutions. And then we have a live demo of booth 29 of the WAN bonding failover in case your fiber breaks, when you have two WAN plugged into the router. And then I'll have some time for questions. I'm not going to keep you guys long. So let's start with the problem. In rural areas, fiber is often limited or completely unavailable. That forces most people to rely on LTE, 5G, or satellite connections, which can be inconsistent. On top of that, terrain, weather, congestion, those things all impact your service and performance. When you add latency into the mix, especially with satellite, it becomes really difficult to support real-time applications. In a lot of these environments, you simply don't have many options. There might be one provider or maybe two, and sometimes there's nothing. Which starts you at a disadvantage. So we'll dive into unreliable connections. And even when you do have a connection, it's not always stable. And that's where we come into play. Signal strength changes, weather affects performance and congestion, can slow everything down, especially during peak times, which I'm sure you all know. High latency is also a big problem. Satellite connections, for example, introduce noticeable delays that might not matter for basic browsing, but for video calls, remote operations, or real-time systems, it becomes a serious problem. And probably the biggest issue we've seen is lack of redundancy. Most sites rely on a single connection, so when that connection fails, it will fail and you'll lose everything. The real problem, one connection is one point of failure. So how do we solve this problem? And how do we fix it? We focus on three things. We increase the reliability, adding redundancy, and improving performance. We'll jump into LAN bonding. This is where the LAN bonding comes in. LAN bonding allows you to combine multiple internet connections into a single unified connection using something called multi-path TCP. Your networking, so instead of relying on just one connection, you can use multiple, for example, LTE, 5G, Starlink, fiber, fixed wireless, whatever solution you have in your area, you can use that. How LAN bonding works. Traffic's distributed across connections. Data is reassembled at the destination, and then we have the automatic failover. So if your first WAN goes down, it automatically fails over to the second one. There's a 30-second delay. Your end user, which would be your customers or wherever this is getting deployed, they notice a small blip, and you wouldn't have those crazy phone calls coming in saying that you guys are stuffed. So instead of having several unreliable connections, you end up with one stable, resilient one. That's just a little diagram of how the WAN bonding would work. A little overview. Benefits of WAN bonding. It eliminates your single point of failure, increases your available bandwidth overall, gives you seamless failover in case one of your LANs die or go out, fiber breaks, trucks running over, whatever it may be. And then you get your stable connectivity. Performance improvements. And from a performance standpoint, you get better video quality, faster application, and far less downtime. Real world impact. In the real world, that translates to reliable communication, continuous operations, and improved productivity. And I said earlier, we are also demonstrating this at Group 29 using real equipment so you can see it firsthand. What is edge networking? Now let's shift to edge networking. Edge networking is about processing data closer to where it's generated instead of sending everything to the cloud. This reduces latency, speeds up decision making, and allows systems to keep running even if connectivity is interrupted. When you add AI into the mix, you get real-time analytics, local intelligence, and automated responses, all happening on site. The benefits are pretty clear. Less bandwidth usage, faster response time, and greater reliability. When you combine WAN bonding with edge networking, you get both reliable connectivity and intelligent local processing. That's what creates true resilient systems. So for use cases, the first one we have is healthcare. This gives you reliable telemedicine, continuous connectivity, and local diagnostics. In education, this gives stable remote learning, consistent access, and reduced disruptions. And for public safety, always-on communication, real-time coordination, and emergency response reliability. And then for agriculture, we get sensor networks, monitoring systems, and data-driven decisions. And then for utilities, we get grid monitoring, predictive maintenance, and reliable infrastructure. A typical deployment includes multiple WAN inputs, a bonding device, and edge computing, all designed to scale as needed. Our system architecture. The architecture is straightforward. Connections come in, get bonded together, processed at the edge, and then connected to the cloud. Our service and design is modular, so we can add or take away whatever's customizable. That's the beauty to it. It's modular. Real-world deployments. These solutions are theoretical. They're already deployed and working in environments today. Feel free to stop by our booth, booth 29, ask questions. We'll have our network engineer there, our outside plant manager will go over how things work. If you take anything away from today, it's this. Reliability is the main challenge, redundancy is the solution, and intelligence improves performance. These technologies are enabling critical services, supporting rural communities, and improving infrastructure overall. Looking ahead, we're going to see more hybrid networks, more edge computing, and continued innovation in this space. And I'll leave you with this. Rural connectivity doesn't have to be perfect, it just needs to be resilient. If you're looking to get started, begin by evaluating your current network, adding redundancy, and exploring edge technologies. And with that, I left a lot of time for questions. So if you guys have any questions, feel free to ask. I know it was quick and short. I hope you guys have some questions.
Sure, all right. So you buy a WAN bonding device.
Yep.
And I stick it between my enterprise network and two upstream providers I buy.
Okay.
That's the question.
Yeah. So our router goes into play. Your networks come in, and then you feed that to your network. So your upstream. I talked to somebody earlier. They had two upstream providers, two fibers coming into their network. We could take those, bond those together. So each are 2.5 gig circuits. You'll get 5 gigs of that.
What is that different than being enabled by our existing router?
What was that?
How is that different than what I'm already doing enabled by existing router?
So our routers have the AI. So one thing I didn't explain is we're in every POP across the U.S. Every major POP will go into Seattle, California. So our latency is lower. With our router that you use, the latency is lower. I don't know what router you're using right now, and if it has the failover capabilities, or if you have to manually go in and switch it if your one fails or not. Ours is provisioned to automatically do that for you, so you have less hassle.
What if that WAN bonding router fails?
You're just talking like just breaks and gives out. We have warranties on we have warranties on our stuff, and we pride ourselves on customer service. So you call us, we'll get a new one to you, and we'll get you squared back away. I think our dispatch time, if we send anybody out, is within 24 hours nationwide, assuming we have the router, and if not, we get that in ASAP.
Is this IEEE standard, or this bonding technology you're referring to?
So our service, our bonding service, is meant to compete with, because it is a service. So you pay for the router, and then the monthly service comes from keeping that latency down. We have 24/7 knock. Our guys respond. So if your stuff goes down, we manage that. We see that goes down. We make sure that our guys give you a call.
You're not touching the packets or anything?
Nope.
How's the difference from load balancing?
So what load balance? So we actually used to use load balancing up in Alaska. We took 10 Starlinks up there, put them on a Connex crate, put them all in there, and it load balanced. What this is doing is you're plugging. Let's just for easy math, each connectivity, like for a residential area, say you need 300 megs at your house, and your Starlink's only getting 100. If you put 3 Starlinks up and plug those in, you're getting that true speed to whatever devices you need. Where from my understanding with load balancing is it doesn't actually give you all of that. But I'm not too sure if you're familiar with Peplink or not. But they have speed fusion capabilities, which is they call it speed fusion. It's the same thing as us, except they charge, I think it's by 50, every 50 gigabits you use, they charge you for that. And then you have to do a bunch of stuff. So that's where we care for the end user, and that's where we're trying to fit in, is to make sure that you guys are taken care of and that we can help you with whatever solution you need. Any other questions?
I kind of missed some of it, but the providers that you're using, are they all are you providing the internet service, the IP for this? Or?
No.
Okay.
So
you can choose from.
Yeah, you can choose whatever you need, or if you need us to reach out for something in your area, we'll kind of do a look and gather some information on what's best for you in your area.
Okay, and then is it just doing BGP then? So it's just doing it that way? Is it organized by BGP?
talking peer-to-peer?
Peer-to-peer, yeah. So the technical question, that one's hard for me to answer. I would direct you to our engineer, which he should be at our booth. So if you want to stop by, Josh should come by and talk to Josh, and he'll kind of explain it a little more in depth.
All right.
So if you had bonded DSL links and a Starlink, you could combine them.
Yep. And one of the main use cases for this is rural connectivity, where, and like I said, a lot of our stuff is in Alaska because they're 5 to 10 years behind on internet, and you run a speed test and you get 5 megs for them, and they're jumping up and down when people.
Latencies in the triple digits.
Yeah.
Is your market residential?
We do both residential and commercial.
Small commercial?
Yep.
Predominantly. Like you're not selling high capacity clients this solution.
No.
They're using a BGP capable router.
Right, yeah. No, our stuff is more like, we do a lot of stuff with tribal governments, tribal entities, small government departments.
Places with no infrastructure.
What was that?
Places with low infrastructure.
Low infrastructure or non-existing, because I didn't know it was a thing, but when you start traveling up to Alaska, you realize people don't have that up there. Then you come back to the lower 48 and you realize that solution is just as worse. That problem is a big problem down here as well, especially like Eastern Oregon area. Sometimes fiber isn't built out to some communities, and you need something to get the speed there. Any other questions? All right. I appreciate you guys' time. Let me know if you guys have any questions. Feel free to stop by for a live demo.